All right, part two of our video for our second lesson, which is comparing two data sets, either from their center or their spread. So the first thing we looked at in the last video was looking at the mean and the median to compare the center, and trying to figure out which of those was more appropriate and in what situation. If you remembered, we said if there is any outlier in the data set, we want to use the median, and if there is no outlier in the data set, we want to use the mean to compare the center of those data sets. Now we're more on to measuring the spread of the data. So if we, in a general sense, if we are trying to determine which data set is more spread out or what that spread looks like, the first thing we're going to look at here is this mean absolute deviation, which can be abbreviated as MAD or your MAD, okay? Mean absolute deviation, it's nice to know what those three words mean. So the word mean, okay, the definition of mean we've talked about, it was even in the last section, you learned it in probably somewhere between 5th and 8th grade, is just another word for average, right? So the word absolute comes from absolute value, which is asking how far is something from zero, the number zero. So imagine in a basic sense, a number line here, right? You have zero, you have one, you have two, you have -1, and you have -2. Imagine a real life scenario where your house is right here, right? And you go out and you go for a run and you run 2 miles this way. And you stop right here. And I say, how far away are you from your house? Your answer would be you're 2 miles away from your house, right? Okay. Fast forward next day, you wake up and you run. This time you want to run a different route. So you run 2 miles this way and you stop. And I say, how far away are you from your house? You're not going to say you're -2 miles away because you can't have a negative distance, right? You can certainly run backwards 2 miles, and I encourage you to try that. I'm sure that would be a lot of fun. But what we're getting at here is that you're still 2 miles away. So the absolute value is it's just saying, hey, what is your distance from zero? Or in that situation of this picture, this lovely picture I've drawn, is how far away are you from your house? These two are not the same number, but if I ask you the absolute value, how far are you from zero? The absolute value in math looks like this. So, well, let's act like I never did that. Okay, that's not that much prettier. This is me saying, what is the absolute value of 2? Well, 2 is 2 away from 0, so it equals 2. This is me saying, what is the absolute value of -2? Well, that's also 2, because -2 is 2 away from 0. So back to, let me clear some space here, but back to that word absolute over on the left. Absolute is just saying how far from 0. This one's saying not absolute. This is saying how the absolute from the mean. So how far away are you from the mean? And your deviation is just how spread apart things are, right? If you maybe in real life you would hear something like, let's not deviate from the plan, let's just stick to the plan, right? Deviation means you're kind of leaving that, you're stretching it out, you're getting spread out, okay? And that kind of leads us into our first blank here. It says the MAD, the mean absolute deviation, is the average distance between each data value and the mean. So it's saying on average, how far are your data points away from the mean? So the first thing you should be thinking is, well, if I'm trying to figure out on average how far away are my distance from my mean, then we need to find what the mean is, right? So that's something we know how to do. You add up all the data points and you divide by how many data points there are. We're going to see that in an example in a minute. It says this really gives us a sense of how close / far the values in a data set are. Are they close together? Or are they far apart? We can certainly see them, but sometimes if we're comparing two data sets and they're pretty darn similar, we're going to want to get an exact measurement to see which one has a greater mean absolute deviation or maybe a smaller mean absolute deviation. So here we're going to hop right into this example, and it's going to let us compare two different data sets. I chose them. They're very small with very friendly numbers. We don't get that very often, but for this example, we will. It says, let's compare two different data sets and compare their mean absolute deviation in just 3 steps, right? As easy as 1, 2, 3, okay? And you see this over here to the left. Number 1, it says find the mean, which we know how to do. We're going to do that together right here. So data set number 1 is these values right here. To find the mean, we add them all up and we divide them by how many numbers there are. So I'm doing 2 plus 4, which is 6, plus 4, which is 10, plus 2, which is 12. And there's a total of 4 numbers there, so I'm going to divide that by 4 and find out that my mean is 3. Okay, so I'm going to put a little star there, right, just to let me know, hey, there's my average on this number line. I have a 2 and a 2 there. I see both those dots on the dot plot, and I have a 4 and a 4 there, and I see both of those dots on the dot plot as well, okay? And my mean is 3, I'm just marking that. My next one here, data set number 2, I'm going to add these 4 values. 1 plus 1 is 2, plus 6 is 8, plus 4 is 12, okay? And again, so I have a total of 12. And from there, I'm going to divide it by 4. And I'm also going to get a mean of 3, okay? That's not because it happens every time. It just happened in this problem. I have the same mean for both of these data sets. I don't have the same mean absolute deviation. I have the same mean. We have just completed step number 1. I'm going to put a check mark next to that here. Number 2, it says find the absolute value of each data point from the mean. So what we're doing down below here, I have these values filled in on the left. I have taken each of the 4 data points, these 4, and I've plugged them into these 4 absolute values. There's the 2 from up above, there's the 4 from up above, there's the 4 from up above, and there's the 2 from up above, all from right here, okay? And then what I'm doing is I'm subtracting the mean. Notice there's a 3 here, a 3 here, a 3 here, and a 3 here, because I need to know the absolute value of the distance from that data point to the mean specifically. So now we're going to go ahead and walk through this, right? So I have here in this space, I'm going to go from left to right this way, and I'm just going to do a little bit of simple math with you. I have here 2 minus 3, which is negative 1. I'm putting that inside those absolute value bars, plus I have 4 minus 3, which is 1, plus I have 4 minus 3 again, which is 1, and I have 2 minus 3 again, which is negative 1. Now, I need the absolute value of those things. So I have 1, negative 1's absolute value is 1, plus 1's absolute value is 1, plus 1's absolute value is 1, plus negative 1's absolute value is 1. So now I'm saying, okay, well, 1 plus 1 plus 1 plus 1 is 4, right? So now I have... So now I have this, the mean absolute deviation of each of these is going to be, I find the mean of your absolute value. So I'm going to do 4 divided by my 4 data points, right? Which is 1. 4 divided by 4 is 1. So my mean absolute deviation is 1. Well, what does that mean? So I want to show you this. It means on average, my data points are exactly 1 spot on this dot plot away from my mean. Here's my mean. We start it, right? If I look at all my data points, look at these ones. This is 4 and this is 4. Well, how far away is 4 from 3? This point is 1 away from 3. This point is 1 away from 3. This point is 1 away from 3. And this point is 1 away from 3. Again, a very, very basic example. And we're saying each of these points on average are 1 space away from our mean on a number line or in our data, okay? Lots of 4s and lots of 1s there. Let's see if we can hop into one where we're going to see some different values and where we have to fill them in. Okay, so first and foremost, what we're going to do over here, we have our 3 marked, is we need to start filling this in. So we need to, in these spaces, start filling in the data set points. So we have a 1, we have a 1, we have a 6, and we have a 4, right? And what are we finding the absolute value from? From the mean. And our mean up above here was a 3. So we have a 3, we have a 3, we have a 3, and we have a 3, right? So we have a little bit of math to do. The absolute value of 1 minus 3. So now we have the absolute value. 1 minus 3 is negative 2, plus 1 minus 3 again here is negative 2, plus 6 minus 3 here is 3. And 4 minus 3 here is 1. Okay, so we have some absolute value. Real quick work to do. The absolute value of negative 2 is 2, plus the absolute value of negative 2 is 2, plus the absolute value of 3 is 3, plus the absolute value of 1 is 1. So I have that addition to do there. So 2 plus 2 is 4, plus 3 is 7, plus 1 is 8. And we need to take 8 and divide it by how many different points did we have? We had 4. 8 divided by 4 is 2. Okay, so what do we notice? Again, can we check this out? It says on average, our data points are 2 spaces away from our mean. Here's our mean, this star. On average, they're 2 away, right? This one's only 1 away. This one is 3 away. This one is 2 away. And this one here is also 2 away. So if you think about it, these both right here are 2 away. Well, that matches right up with this. That makes sense. This one's 1 away. This one's 3 away. Well, what's in between 1 and 3 if I average those out, right? 1 plus 3 is 4 divided by 2 is 2, right? 2 is the number that's in between 1 and 3. That's saying that these spots on average are 2 spaces away from my mean. Now, what does that tell us? In general, it tells us, right, that this number being larger for this data set means that that bigger number means the data is more spread out. On average, they're 2 spaces away, where on this first data set, they're 1 space away. Could I have seen that if I just looked, if I just used my eyes? Yeah, absolutely, right? I can tell, knowing that this is the mean here, that these are generally closer on average than these, okay? Again, a very basic example. Can we always tell by looking? Absolutely not. We're going to see an example where they're definitely more spaced out, and you can see the mean absolute deviation in a more difficult situation, okay? So what does it tell us? It tells us that data set number one has a smaller spread, comma, and its values are closer to the mean. I'm also going to MEAN, mean. I'm also going to mention, and maybe that data set number one is also, let's call it a comma, and the data is more predictable. Okay, so it's just saying, hey, we can make, if we have another up here, if say, I'll make this up, this is the age of the kindergarten class, and there's 4 kindergartners in this class, right? There's 4 dots. No, that's not a great example. Let's go this. It's the amount of, I don't know, the chapters you read in the last 4 nights, right? If I say you're going to read for a 5th night, we have a pretty nice tight window of how many chapters you're probably going to read. It's probably going to be 2, 3, or 4. This one here, right, over on the right side from data set number 2, if I say, hey, these are the last 4 nights chapters you read, it's a lot less predictable. You might be reading 1 or 2 or 3 or 4 or 5 or 6. They're more spread out. It's less predictable. The data is more spread out there for measuring the spread, okay? We mentioned this earlier with IQR. So the IQR stands for the interquartile range, okay? The interquartile range, it has here, the IQR is the middle 50% of the data, and it shows us how spread out the data is from the center / median. Okay, so that median again is right there smack dab in the middle. We know that our IQR is, its general recipe there is quartile 3 minus quartile 1 gives you your IQR, right? Which would be that middle 50%. We mentioned earlier, I can't stress this enough. This first piece is 25%. This piece is 25%. This piece is 25%. And this upper whisker here is 25%. And again, you're going to see on all 4 of those, they might not be the same size, but they represent the same percentage of data. So the IQR specifically goes from here to here. So that's your middle 50% of data. You can certainly make claims about that, as we saw up here in the earlier problem, looking at Caitlin and Philip's school, right? We can make a claim like I think we said this earlier, but the middle 50% of Caitlin's school was a lot less predictable than the middle 50% of Philip's school, right? He was going from something like $45 raised to $56 raised for the middle 50% of students, whereas Caitlin's students were something like $32 raised all the way up to $52 raised. It's a lot less a lot more of a big spread for Caitlin's school than it was for Philip's school there, finding that IQR. We would say the IQR here is 11 because 56 minus 45 is 11, and the IQR here is 20. So we have a much bigger span of numbers in play and a much larger spread for Caitlin's school, which makes less predictability and more variability. Okay. I'm going to let you guys take an opportunity to take this information down below and put it to work on an Edulastic and ask Mr. Shannon or I or your Algebra 1 teachers any questions that you guys have. You'll see some questions like this, and we're going to send a practice your way that has you doing some of these 3 steps here and over here to find the mean absolute deviation of some specific data sets and finding, which one has more predictability and which ones have a more close spread. Okay. Appreciate you guys following along, and we will talk soon.